Yeah, let's move on to the next session on the agenda. We have Dr. Rukshan Batuwita. He's going to talk about data science in marketing and advertising. And yeah, he's been working in data science, applied machine learning for the last 14 years. Previously, he worked as a lead data scientist at Woolworth Group and a senior data scientist at Ambiata Limited, Australia, where he was a founding employee. During his time in academia, he held research positions in machine learning at National ICT Australia, MIT, and Imperial College London. He completed his PhD in machine learning at the University of Oxford, UK, and his BSc Computer Science and Statistics from the University of Peradeniya. Yeah, I'd like to thank Dr. Rukshan for coming to, being available to do this presentation, and I would ask him to continue his presentation.
Thanks, Dr. Shehan. Hopefully you can hear me.
Yes, we can hear you.
All right. Okay, great. I'll try to share my screen.
You can have your video if you want.
Maybe I'll keep it close because I can say some bandwidth for the presentation.
Fine,
so you'll hear me better. Probably at the end. Yeah, maybe I'll have my video at the end. So can you see my screen? Can you give me a little shout?
Yes, we can see your screen, but it's not on full presentation mode here. Yeah, now it's okay. Yeah.
Okay, I went to the full presentation mode. All right, great. Yeah, yeah. Thanks a lot, Dr. Shehan, and the organizing committee of DataSEARCH for inviting me for this occasion. A really pleasure to be here, and also I would like to share my thoughts around data science applications in marketing and advertising. And thanks to Dr. Pan just setting the scene of talking a little bit about marketing and business side of applications in data science as well. I think that would help me to do my job better. And first of all, a little bit of a disclaimer as well. So in this presentation, I'm not officially representing Google, even though I work there at the moment. So this is in this session, it's all mine. Cool, let's start then. So first of all, we'll look at why we need to do marketing and advertising, right? So if you think about an organization, right? So organizations would have customers, right? It can be a bank, supermarkets, telco, and whatnot. So usually if you think about a customer journey, customer would go through different stages in that with that organization. Probably the customer would join an organization initially, then second, after that, they would establish in the organization, they will start acquiring the products and services of the organization. Finally, then they churn away from their organization. So with respect to each of these stages of the customer journey, these organizations would have different business objectives. For example, at the joining phase, the organizations want to acquire more customers at a lower cost, right? So then in this existing customer base, what they want to do is they want to improve or they grow the existing customer base. That is that they grow the revenue or the profit with the existing customer base by just upselling and cross-selling of their products. Finally, they want to reduce churn or improve the retention of the customers. So in order to achieve these objectives, the companies usually, or the organizations usually run marketing and advertising, right? So that's why we need to consider marketing and advertising, right? So next we look at the concept of different marketing channels. Nowadays, companies would market and advertise their products and services across multiple channels, right? Traditionally, we know that we have channels like TV, radio, printed media like newspaper, articles, leaflets, and things like that, then direct mails, telephone, and SMSs. In addition to that, nowadays we have digital media, so which composed of like channels like email, search advertising, and display. These are the like still image advertising that you see in the web, called banners, for example. And you also have the video advertising, right? So next we'll dive into some of these data science applications in the area of marketing and advertising. And first of all, we'll look at the main objective of applying data science methods in marketing and advertising, right? So the main objective is to apply data science and machine learning methods is to improve something called the marketing ROI, that is the return of investment of marketing. That is that how we can improve if you spend $1 or 1 rupee in marketing, how we can increase the amount of revenue or the profit that you bring back to the organization, right? So the data science applications we can develop to improve marketing ROI can be developed at different levels. We can develop them at organization level. We can develop them at advertising campaign level. Next, creative or the ad level. And finally, the customer level, what you call as the personalization solutions. Next, what you're going to do is we are going to look at each of these, the solutions that you can develop at each of these levels and talk about those solutions in a bit more detail. Right? First, we'll start with the organization level. So one such method many companies used to improve the marketing activities at the organization level is something called the forecasting methods. So in forecasting, what we do is we use the historical value of different business metrics. This can be demand, supply, sales, revenue, etc., to predict the future value, right? Basically, to do this kind of a predict, kind of a modeling or predict the future value, we have to use time series methods, as you may know. So there are different types of time series methods people apply. There's a different category of methods called time domain modeling methods. So classical methods like ARMA, ARIMA, ARCH, these kind of methods, if you know about this. And also we have the structured time series methods falling into that category. Then we have a set of methods borrowed from frequency domain methods like fast Fourier transform and that kind of related methods. Nowadays, people apply a lot of deep learning as well. For example, the methods like recurrent neural networks with LSTMs and other types of architectures to build these forecasting methods to predict the future. Once you can successfully predict any of these business metrics, that we can do is we can optimize the marketing budget. For example, if you can predict that particular time of the year, right? So the demand for your products and services is going to get increased, then you can increase the marketing budget accordingly, right? So that's the application there. So second off, so another sort of like the application at the organization level is called the marketing mix models. So the whole idea of marketing mix model is how we can, first of all, how we can estimate the return of investment across different digital channels that we use. For example, historically, as I mentioned, a particular company may have used different media channels like all the channels that we discussed previously, and they spend different marketing budgets. And they also observed the total revenue, not only for that particular channel, but in general for that particular period. It can be a week or it can be a day. What's the total revenue that they observed, right? You can use this historical data to build something called the marketing mix model. So it can be modeled as normally a multiple linear regression model, or nowadays people apply some Bayesian regression models. So the outcome of this kind of a model can be twofold. One application or one outcome can be, as I mentioned previously, you can easily measure the ROI, the return of investment of each of these channels, right, using this data and using this marketing mix modeling. The second advantage is, right, once we have such a model, once we estimated these ROIs, you can, if you have a new marketing budget, you can use the model to run different kind of scenarios, right, and then try to get the optimal allocation of your budget across these different channels to optimize whatever the KPI or the metric that you're interested in optimizing. It can be revenue, profit, or the acquisition, the total number of conversions, or whatever, right? So that's about marketing mix models. And another application at the organization level, right, that people use to, especially to estimate the effect of digital channels or digital marketing channels, is called attribution modeling. So this is the main concept of attribution modeling. Assume that a company run a website, people can go to the website and purchase different services and products. Let's say a particular customer, right? So they receive an email from that company as part of the email campaign. They go to the web, that they don't do a purchase. And the next time they see an ad somewhere in a website, in the internet, on the same company, they click on that ad, go to the website, still they don't make the purchase. The third time what they do is, now they want to purchase something from the website because they know that what they sell and or the products and services. At that time, what they can do is they can go to the internet and search for that company, right? Then they click on a search ad, then you can go to the website and purchase that item. So that's the pathway for purchasing for the customer one. Let's say for the customer two, first he has seen a video ad, no purchase. Second time is a banner ad, going to the website and doing a purchase, right? So in those kind of scenarios, how would you attribute this purchase, right, to which channel, right? So are you going to attribute this purchase to the last, right, channel the customer came through, or are you going to attribute this purchase across all the digital channels the customer went through who had a particular advertising, right, from this particular company? So for this attribution, people use different types of models, what I call the fixed models. That is that if you want, you can attribute this purchase to the last channel or the first channel, or you can distribute the weight equally across multiple channels. At the same time, once you collect this data, you can use the data-driven kind of models. Like you can use models like hidden Markov models, linear regression, Shapley value kind of attribution models, right? To attribute, right, the effect of these different channels to these purchases, right? So once we have that data, basically you can focus your marketing budget and effort of most of those productive or profitable channels than others, right? So that's called the attribution modeling. Right. So next we look at, so we discussed the first one, that is what are those data science applications at the organization level. Next we look at what are those applications at the campaign level. Let's say you want to run a marketing campaign, right? So what are the data science, how the data science applications or the methodologies can help you to do that, the campaign better, right? So first of all, what's called the A/B testing. So usually you have to, if you want to measure, right, the effectiveness of a particular marketing campaign, you usually have to use some sort of a experimentation and measurement framework. Usually people use something called A/B testing for that. So there are two types of A/B testing, right? You're running this, setting these experiments and measurements. The first one is called the customer space. This is the simplest method. That is that what you can do is simply, you can randomly reward your customer, right? It can be some sort of stratified random sampling or pure random sampling based on the different attributes that you collect about the customers. You can divide into a similar audience of test group and a control group. So there basically people use statistical experimental design. That's sort of the data science methodologies people use, like to estimate things like sample size, what's the budget, and how long you want to run this experiment to get some statistically significant results at the end, right? So then for the test group, once you set up those proper groups, test and control, then you can, for the test group, you can run the campaign. For the control group, you can do nothing. So then once we have the results, again, you have to apply some statistical significant tests, right? The proper ones, depending on the metric that you're going to observe, to measure the effect that you estimated due to this marketing campaign is statistically significant or not, right? So that's the first type, called customer split. So there are some situations that you can't do a customer split, right? In that case, you have to run something called the geo split. That is that in these kind of experiments are also called running controlled experiments without having a proper control or a natural control. So in this case, sometimes what people do is they run campaigns in a particular state, let's say in a particular district or a province in the country. You run the campaign, and another province you can use as a control state, right? Again, you can use statistical experimental design to find out what are those states that you had used as test and control states. At the same time, budget estimation and how long you want to run this experiment for. Then once you have the results, you know that you can't directly compare these two states because they may not be identical states, right? Then you have to do something called, a counterfactual modeling. That is that you use the results of the control state to predict the counterfactual of the test states. That is, if you didn't run this campaign, what would have been the result of this particular metric in that test state? Then you can compare apples to apples after that. For that, basically, people use the structural time series modeling methods to do this counterfactual prediction. At the same time, after that, you can apply statistical significant tests to measure the effect of this campaign. So that's about A/B testing, right? Next, we look at some of the applications at the creative level. So what I mean by creative is these corresponding ad or the videos. Can be a simpler display ad or a video or a text ad, right? So that you used in your campaign. So what you can do is basically using some machine learning methods, you can extract some characteristics of these ads or the creatives, right? It can be the text, language, the font size, color, what are the objects in that particular display ad, what are the sort of the color, so and so forth, and also things like voice as well, right? You can, if it's a video ad, you can do some analysis of the voice of that ad. So then by extracting these different elements, then you can build a machine learning or statistical model on top of that to correlate that with any metric that you're interested in. Say you want to, the metric that you're interested in is something called the click-through rate. Click-through rate is the probability of someone clicking on that ad, or it can be something related to revenue as well. Then once you build such model by just looking at the effects of different coefficients of, if you build for example, something like a linear regression model or something like that, then to estimate the importance of each of these elements, metric that you're trying to optimize using that ad, right? So then once you have that knowledge, what you can do is you can try to create some new ads or new creatives having more of those elements that have a high impact of the metric that you're trying to optimize. So that's about the creative analysis, right? Okay, so next what you're going to look at is some applications at the customer level. So far we have discussed some applications at the organization level, then we discussed some applications at the campaign level, creative level. Finally, we have some applications at the customers level, right? So, or sometimes we call that as personalization applications for marketing, right? The first such application is customer segmentation. The purpose of that is basically to understand the composition of your customer base. So how we do that? Basically, once we have all the characteristics of the customers, what you call as features, it can be their demographics, transactional behavior, or any other feature that you have collected about the customers. Basically, you can apply standard classical clustering methods like k-means, hierarchical, model-based, whatnot, to find out what are the meaningful groups that you can find within that customer base. So there are two types of clustering methods. Standard clustering, where you use all the features, all the characteristics of customers to find these segments. Or there's a set of clustering methods called bi-clustering or co-clustering, where what you can do is you can try to use a subset of these features to find different groups which are similar to each other, right? So at the same time, people apply a lot of dimensional reduction, embedding or encoding methods to reduce those high dimensional feature spaces into something like 2 or 3 dimensions, so you can visualize the data in some way, so you can try to understand these clusters or the natural segment of those populations, right, visually. So those are the methods that people apply for, basically, for segmentation, right? So next we talk a little bit about the predictive modeling applications and how we can use those predictive modeling applications to optimize marketing. So one such application is called propensity modeling, right? So the whole idea of propensity modeling is, right, think about, you have a customer, you have all the historical information about that customer, like his demographics, all the transactional behavior, interactions with the organizations and everything, right, that you record. Then what you can do is you can use that data, right, build a propensity model to predict the customer's future behavior at the individual level. So this can be customers' propensity or probability to do some action in the future, right, a well-defined time period into the future. It can be propensity to subscribe to a new service, propensity to purchase a new item, propensity to even churn away from an organization, right, stuff like that. So how do you do it, right? So as I mentioned previously, using historical data, right? You use historical data to build the model, as some of you may know. So we use all these the data that you collect, right, as what we call as customer features. And also we collect the historical label, that is what the customer has performed with the historical data, right? That can be a purchase event and whatnot, if it is a propensity to purchase model. And we build a propensity model. It can be something like a classification model in machine learning, right? So then once you build the model, at the application time, what you can do is, this is one such example, how you can apply a propensity model, right? So then you can, using this model, you can predict what the customer is going to do within next week, next 2 weeks, next 1 month, and so forth. Then using that propensity signal, then you can divide or rank the customers into different groups, like high propensity versus low propensity, right? So then let's say, you can then do some interesting different actions for these different groups, right? So if the customer has a high propensity to purchase something, maybe you don't want to persuade that customer too much, right, of purchasing. You can try to send a lower offer or discount if you want, right? If it is a customer having a lower propensity, right, then you can try to send a higher discount because you want to pursue the customer more. So that's one such application of how you can use propensity modeling to optimize your marketing, right? So another type of modeling called customer lifetime value modeling. So there what you do is basically, again, you use the customer past data to, instead of trying to predict a sort of like a binary or label into the future, what you're trying to do here is you're trying to predict some sort of a value that the customer would bring into the organization in long term. So this can be the total revenue from that customer into the future, or kind of something like a total profit, right? Some sort of a numerical figure. So again, once we have that number, you can divide customers into high, low, medium, and whatnot, and make some different marketing actions, right, for these customers. Another application we can talk about is something called recommender systems, right? So the whole idea of recommender system is, can you use the historical purchase behavior of that customer plus similar customers, right, to recommend or predict the propensity of this customer buying different products, right? So one of the techniques used to build recommender systems is mainly called collaborative filtering. The main idea of collaborative filtering is, let's say you have two customers, customer A and customer B. Customer A, say customer A has purchased all these machine learning books and statistical learning books, right? Let's say customer B has purchased 4 of these books, right? Not the last one is the most famous deep learning book, right? And based on this behavior, you can train a system, right, to predict this or recommend this deep learning book for the customer B, right? So that's the whole idea of recommender system, right? So in order to solve this problem, people use different techniques like matrix factorization. That's the classical, most popular classical method people use. But in addition to that, you can use matrix factorization with customer features, and people use techniques called factorization machines. Nowadays, people use a lot of deep learning techniques as well to build recommender systems. Right. All right. So next we'll talk about another interesting application of personalization that's called the response modeling. So the whole idea of response modeling is, right, how we can try to allocate the right offer or the right ad, sometimes we call it as a treatment as well, to the right customer, right? Because there are customers, let's say once you send an advertising or a offer to a particular customer, some customers are happy because their, let's say, propensity to purchase or probability to purchase something can go up, right? For some customers, regardless of the offers that you send or the discount that you give to customers, right, they are not going to change their mind, right? They are not going to buy at all. So they are going to always not bias. And there are some other customers, right, regardless of you send something or not, they are going to buy anyway, who are always biased, right? And also there are some customers, right, if you send the wrong offer at the wrong time, right, they may not like to basically to purchase. That is that their propensity to purchase or probability to purchase a particular item can go down, right? So in that case, you have to select the first group, who we call as a persuaders, right? Only the customers whose probability would go up only if you send an offer, right? So that's the most, I think, optimal way to optimize your campaign, right? So in order to run and optimize such a campaign, you use a modeling technique called response modeling. So there are 3 phases of this kind of technique. First one is called exploration. In this phase, what you do is you try to send a random offer, right? You select a customer, you try to allocate that customer with a random offer or an ad with the offer pool or ad pool that you have, right? Then you observe how these customers would respond to that. In the phase 2, what you call the modeling, there what you do is you build something called a response model. In a response model, what you do is, in addition to the customer's historical behavior, you try to include the ad or the offer that you allocate to that customer as an additional signal to capture that treatment effect, right? So then if you have a response model, what you can do is you can select the best offer that you should have to allocate to a particular customer to optimize whatever the outcome that you're trying to optimize. It can be the propensity, or it can be the lifetime value model, or anything like that, right? So that's the phase 2. In the phase 3, what you do is, once you have this model, right, you can use this model to keep allocating the best offer or the ad to the particular customer, which is called the exploitation, exploiting the knowledge that you have learned through this model. Then, as you know, customers change their behavior as they go due to different reasons. In that case, what you do is, let's say for the 10% of the customer base that you randomly select, you still run this random campaign, right? So in that case, what you can do is, in continuous basis, you can learn and update the model or the policy that you will learn in phase 2, right? So in order to balance this exploration and exploitation, people use a technique called multi-arm contextual bandits. That's the technique mainly used in computational advertising, right? All right, so next, actually, this is my last slide. So so the next solution I would like to introduce something called next best offer engines, right? You can think of next best offer engine as the sort of the holy grail of personal marketing. That is that how we can build a system that can recommend to the right offer or the right ad to the right customer at the right time through the right channel to optimize the right objective, right? So you can try to use the multi-arm contextual bandit approaches that I briefly introduced in the previous slide to build this kind of a model. Or if you're interested in optimizing not only the next action of the customer, you want to optimize a series of actions into the future, right? You can try to use some reinforcement methods to do this as well, right? So yes, I think that's mainly I want to cover. And thanks a lot. And if you have any questions, I'm happy to answer. Right. So yeah, there are 2 questions. So are there any live questions before can I go to the Q&A?
Yeah, Rukshan, thanks. You can take the questions on the Q&A.
Okay. Yeah. Thanks, Dr. Amar. Yeah, there's 2 questions from Nisanka. The first one is there are a lot of publications out there at the moment. It's difficult to see the forest from the trees. Can you recommend a good learning users evaluation? Yeah, that's right. So I think it's a general question. So I'll summarize the question. There's so many publications out there, right, talking about different methods and applications of things. I think you are especially interested about MMN attribution modeling. So I think what I would say is you can start with an approach that is in a textbook, right? Rather than looking at the publication. Normally the publications would contain the cutting edge advancement of a particular area or a technique, but it's always go back to the basics and try to use the vanilla version of that, right? That you can find in a textbook and apply that and see how it goes. Then move into the publications if you want to improve on top of that. So that's my advantage there. The second question is, what is your opinion on causal modeling in machine learning? I see an attempt to do that in economic. Yeah, so the second question is about causal modeling machine learning, right? So people actually, if you have seen the work of someone like Judah Pearl, so he has a book on sort of causal modeling and related to machine learning as well. And also there's something called causal networks, which is similar to Bayesian networks, but in addition to learning causality between, a correlation between variables, using causal networks, you can try to learn the causality in addition to correlations, right? So I think there are in branch of machine learning, right, work on the causal modeling aspect as well. And also there are different areas. So as I mentioned, if you're interested, you can look into the work of Judah Pearl. And also, if you can send me an email, I can recommend a couple of other sources as well. But there's a considerable effort happening in machine learning in the area of causal learning as well. So, okay, next, move to the next question. In a geospit model, how can identify people from the So in a geospit model, how can identify people from that exact geographic location, especially online? Actually, yeah, so the whole purpose of applying a geospit model is not to identify two similar geos. You can perfectly use 2 different geos, having 2 different types of people to set up that experiment. Then, as I mentioned, you have to use the control geo signal to build a counterfactual model for the test geo to predict the counterfactual metric. That is, that if you didn't run that particular campaign on the test geo, what would have been the value for that metric you're interested in, right? Then you can compare of that prediction with the actual value of the same geo to get that difference, right? Again, yeah, it's a bit more complicated, but if you can connect with me offline, I can send you some materials for you to refer. Right? Okay, next question. Yeah, in NBO engine, what kind of input variable will be? Can you explain a bit? So yeah, in the next best of engine, basically, you can think of that as an extension of a response model. In that, basically, you can have all the natural characteristics of the customer that you normally include in modeling. Plus, you can try to include this offer or the treatment that you're trying to optimize, right, or to allocate as an additional variable into that model. Right, so that's how we can formulate that, and there are different formulation of those models. If you look into the literature of uplift modeling, it's the same idea of response modeling. All right, I think that's all the questions, I guess. Am I missing anything? Or is that all the questions?
We have, yeah. Thanks, Dr. Rukshan, for that presentation, and yeah, we will move on to 4 presentations from the researchers at DataSEARCH. They're going to be very